Daniel, welcome to Talk Satellite. Delighted to have you join us today.
Thanks for having me.
So when it comes to Department of Defense and NATO SATCOM, what should industry be focused on in terms of standardization, interoperability and digitization, given the near-peer threat landscape?
Well, I think there's really two threads there. The way that we've seen the industry evolve over the last couple of years, there's this separation between the hardware that's being used and the capabilities that are being run over that hardware. We've seen some tremendous effort over the last couple of years to standardize around common hardware systems, and organizations like the Digital Intermediate Frequency Interface Consortium, DIFI, are doing some great work in making sure that the pieces of hardware that are out there providing digitization of the analog signals going over satellite are built around a standard. They're interoperable across vendors. At the same time, there's this heavy focus on delivering the right set of capabilities over those common hardware platforms. And so that's protected and assured waveforms, its capabilities to adapt and change your network based on adversarial actions. And really kind of the key that we're seeing today is getting the interplay between those two areas working, making sure you have the right hardware to run those capabilities, but then also the right suite of tools available to deploy based on the changing environment.
Comtech has been a strong advocate for open standards and key player in the DIFI consortium. How does your digital common ground portfolio reflect that commitment, and what impact is it having on the coalition operations?
Well, I think this was something that we asked ourselves early on in the process, what we believed about the future, and then how do we show that commitment? And one of the key things is the digital common ground portfolio is built primarily around DIFI interfaces. And obviously we've thought about the systems, and we recognize that recapitalization of existing hardware is both time-consuming and expensive. And so we do support legacy intermediate frequency L-band interfaces, but we've built a portfolio around supporting DIFI, supporting L-band simultaneously in next-generation ground architectures, and helping ease that transition for customers that may have a 10 or 15-year recapitalization period.
Follower, what capabilities are we actually looking at?
So on the digital common ground platform, we've kind of lumped these into a couple of categories. And the first is, we refer to as ultra wideband communications modems. And so those are 500 plus megasymbol, very high throughput, 1 gigabit per second. A couple of the platforms up to 8 gigabit per second on the hub side, as well as, very high symbol rate spreading capabilities. We've got a couple of very small form factor capabilities with our DCG 7000 series, and those are really targeted at small, like unmanned vehicle type applications supporting, drone swarm connectivity. And then the last element is what we refer to as our 8000 series, or DIFSID, the Digital IF Combiner Divider. And that's a very wideband 1+ gigahertz digitization tool that allows for the transition out of analog communication signals so they can be taken in and processed by another piece of hardware. And whether that's a satellite modem or whether that's general purpose compute that's being used to demodulate that DIFI signal.
How are governments implementing programs that enable industry to best address SATCOM requirements for the end user?
I think one of the great things that we've seen is governments more and more are describing capabilities and use cases rather than a defined set of requirements. And I think that's allowing industry to move forward and sometimes innovate a little bit faster than you can get things through the requirements process. We've seen, certainly there are some traditional programs that have been successful. One of the things we're really excited about is the U.S. Army Enterprise Digital Intermediate Frequency Multi-Carrier Modem, the EDIM platform that we're in the process of conducting, final production or prototyping phases, and we'll be delivering the first 40 or so units towards the end of this calendar year.
What trends are you seeing in the government SATCOM sector?
I think there's a couple of trends, right? And the first is there's a lot of caution around new capabilities. And I think a lot of the government users have seen some of the risks of getting something that you don't fully understand. And so people are looking thoughtfully, but at the same time, the disruption created by some of the new capabilities, I think is really interesting. And they're highly focused on, how do I make sure that I don't break what I have while still being able to use the next generation capabilities? Whether that's direct-to-device, 5G NTN type capabilities, or some of the commercial LEO satellite capabilities, they're really focused on bringing those in and using them alongside the legacy portfolio of communications tools.
What next for Comtech?
Well, I think we're really focused on working with both our customers and our partner network on bringing relevant capabilities out at the right pace. And we announced just a couple of months ago that we had certified the SLM 5650B to operate on the SES mPOWER constellation. I think that's a huge win for our customers. It brings the fielded infrastructure and the satellite modems and terminals that are already in the field onto that next generation SES mPOWER network. I think a huge win for those users everywhere to add a level level of resilience and an additional network capability onto fielded platforms without the need to return them. Our focus continues to be on how do we bring those new capabilities to bear through software-defined systems, with a recognition that for a lot of our customers, it's resource-intensive and difficult to get equipment out of the field. Software upgrades, higher frequencies, higher throughputs. That's the future for Comtech over the next couple of years.
Daniel, thank you very much.
Thanks very much for having me.